Welcome to the Eonics Podcast, a podcast about software engineering, new ways of working, and lots of other interesting stuff. We have a returning guest here, Jeroen Vermeulen. Welcome.
Thank you.
You worked for Eonics quite a while, but now you work at Cisco, I believe.
That's right.
And today we wanted to talk about one of your favorite topics, C++.
Right.
Why does it still exist is my first question.
It does. The US government, the White House, has just issued an executive order saying, please don't use languages like that. But of course, all the infrastructure we use is written in C, C++. Even if it's written in other languages, usually the infrastructure for those languages is written in C or C++.
Right. And you have been using it for a long, long time, right?
A while now, yeah.
Yeah, and you maintain what is it again? The
C++ API for PostgreSQL.
For PostgreSQL. Yeah. So you have been continuously using it and updating to the new versions and all that stuff. Because why would I choose to use C++ in 2024?
You wouldn't do it for most tasks, right?
Okay.
My personal mix is you do everything in Python unless it needs to be really, really fast, and then you do C++.
Okay. So for speed is one of the reasons why you would use it.
A lot of game developers use C++, for instance.
Right. So is that also the reason why, for example, the database bindings in C++ are important? When people want to write really performant applications on a database, they would use maybe C++?
I think so. C++ has really been moving again in recent years, right? As of 2011, we got a new standard and a new cadence of, every 3 years or so, there's a new C++ standard.
Really? Is it so often still?
Yep.
So it's really active language, actually?
It is now, yeah. But from 2003 to 2011, there was basically nothing.
Oh, so it really got reinvigorated at some point.
Yeah.
What was the reason? Was there a specific reason for that?
Well, let's be honest, C++ is a bit of a mess, like any mature language, right? It grows warts everywhere, hairs pop up.
Right.
It's like a city,
Yeah, you get ugly neighborhoods.
Exactly. And so they wanted C++ to be easier. They wanted C++ to be safer because, pointers are dangerous, especially in the wrong hands.
Very dangerous.
Oh, God, yes. And they wanted it to be a more modern language. They wanted things like asynchronous programming, for instance. And C++ is in a somewhat unique position because, on the one hand, they want it to be an applications programming language. To some extent, I think that ship has sailed. We've got application programming languages like Java or Python. We write applications in those. And then we've got systems programming languages where you have to be able to control everything.
Right.
But it's good that the two learn from each other. So I think the Go language, for instance, is still advertised as a systems programming language, even though you can't use it for that, right? It's not a systems programming language. They just left it on there.
Isn't Rust the big newcomer in that field?
It is. I think to some extent it suffers from the same tragedy that people are developing a systems language in order to write applications.
Okay, yeah.
Right. I think for decades we tried to have that distinction, and it finally came and nobody noticed. But also the other tragedy, I think, of Rust. I like Rust. It's not a pretty language to look at, but I think the Rust developers are very honest about what they want, what they need, what problems they're trying to address, that sort of thing. But there's a very high threshold. Getting going with Rust, you have to get into the mindset. And that's difficult. We can build huge machines, but the hardest thing to move, arguably, is still a human mind or a human opinion.
Right. So is that also where C++ still have its function?
Right.
Like embedded systems, maybe, for example, is I think where
That
they still
too.
use it a lot, right? That kind of thing.
There's that, yes. Stuff like the F-35 fighter jet.
Ah,
Right.
so industrial, military applications, that kind of thing.
And you get a lot of computing power, right? It's not just that you don't have enough computing power or enough memory. It's also you need to process huge amounts of data. And C++ covers that range. It because it can function as a test bed for all the new ideas. So languages do new things. Things like Rust's, the borrowing...
Borrow checker.
Borrow checker. These concepts can first be explored in C++ as libraries without being part of the standard, without being part of the language. And the other thing is that C++, because it pioneered, well, they weren't the first, but because it had to explore routes for things like make a user-friendly string. I mean, you wouldn't believe how long it took them to make a user-friendly string class. At one point, at one of the standards meetings, somebody said, look, if we reconvene in a year and we will have no plan for a string class, there will be blood in the streets.
Right.
He used that phrase, blood in the streets. And people went, oh dear, I don't want blood in the streets. And they thought about it, they went home, and they came back with a plan for a string class. It's been very slow, very painful, but you can do all the low-level stuff in C++.
So what is the newest stuff that has been happening then in recent years?
A lot of performance work. So for instance, in the C++ API for Postgres, I can now retrieve data faster than you could through the C API, really.
And why is that?
Well, first, why not? And the answer to that would be because my library is a wrapper on top of the C library. So I call the C library, and yet I'm faster.
Really?
Yep. And why is that? Well, one of the reasons is you have lots of code that deals with text, and it has to be very fast, but you have to scan characters. Let's say you've got text in UTF-8, and you need to find the next double quote character to find the end of a string. Sounds really easy. What they used to do is just look for that byte. But if you've got a difficult encoding like the Japanese SJIS 620, I think it's called, you can have a multi-byte character that contains a byte that looks exactly like an ASCII double quote.
But isn't.
Semantically
speaking.
Right. So you need to do all of that, but you cannot afford to write one loop that goes through the text and looks for the closing quote if it has a dozen different ways of finding the next character.
Right.
Because the inner loop is what drives your performance cost. So in C++, it's really easy to write that code once and say, here you make a function call to a function that I give you. But you let the compiler generate different binary code for every encoding.
Ah, okay.
So, yeah.
So that's why it's, and that's something you wouldn't be able to do in C.
Not easily.
Not
it's a
easily.
lot of work to
right,
do in C.
Because you would have to manually code all those different.
Yeah.
Ah, I see what you mean. And this might be a stupid question, but is C++ at all working on doing, stuff with like cloud or functional programming or like all this kind of modern stuff?
Well, functional programming is very old.
Yeah, functional programming is very old, but it's newer that it's integrated in more traditional languages like Java and stuff.
Well, I would argue that this is exactly the sort of thing that we could do in C++ without changing the language for it.
Ah, okay.
So we already had support for functional programming. Whether you did functional programming, that was your own problem.
Yeah, sure.
Cloud is a bit of a different issue. Arguably, the one big feature for that would be that I could think of at programming language level is asynchronous programming, which is actually a very old idea, right? It was called multi-programming in the 1950s, I think. And we almost got the same keywords for this as in Python. But here we go again with the the simile of a city. Everything's grown into place. You can't just change things.
Right.
So when they do something like this, when they add a feature like this, they have to do this massive investigation to find out if anybody was already using those words as variable names, as function names, and if too many people were using them.
They're not gonna use them.
Right. So words like await. Well, we can't have an await, so we ended up with CO_await. Lost opportunity.
That's a bummer.
Yeah.
So, would it make sense to learn C++ if you don't already know it? Or is it just maybe for fun or for educational value? Or do you think it has real value?
Well, I would say don't underestimate the educational value.
Yeah, that's true. But would you, let's say someone doesn't know C either, would you say learn C first, or would you say, yeah, learn C++, that's fine, see how it goes?
I would say, yes, just go ahead and learn C++, which is not to say that C is bad. C is also an interesting language to learn, but it doesn't support abstraction quite as well. And that is very, very important in C++, that it doesn't have abstraction built in, but it supports abstraction.
That'd be a stupid question. What you mean by abstraction here?
The encapsulation, the separation of concerns.
Oh, right.
So, for example, if in Go I create a type, and it has all sorts of complex things inside, right? You can treat it as an object.
Right.
That's nice, it's convenient, you don't have to know about the details. But by default, it's 0 initialized. Now I add a field, could be a file handle or something. I add a field that you absolutely have to initialize. You have to run some code to initialize it.
Right.
Now, all your existing code assumed that it could just create the object and it would be correctly initialized. Now you have to go and find all the places where you do that. And of course, there's tools for that, right? But you have to find all the places where you create those objects and change them all to call your constructor because you didn't have one before. It's just one example that springs to mind, right, of how you can help people create boundaries, because the ultimate limitation on the software we can write is the limitations of the human mind. Right? You have to separate things into chunks that are small enough that we can understand them,
Yeah.
but big enough that you don't get lots and lots of chunks that fit together and you get the same problem again.
Yeah, but then with how the chunks fit together.
Exactly.
Right. And so your argument is that C++ does in a way quite a good job at balancing that.
I think so, yeah.
So it's a good language to learn. How does it compare to Java nowadays?
The ecosystem for Java is obviously much more supportive of a software engineer's job. So
yeah, you mean like just simple things like libraries and Spring Boot and like all this kind of stuff.
IDEs, frameworks,
right.
all that stuff. Yeah, that all happens in Java. It's wonderful to see. It's not my thing, right? I have my own preferences. But C++ happens still mostly, you could argue, in your own head or in your text editor. There's people who use Visual Studio, for instance, and it can help. But I do not see the best code coming out of there. So
it's more, how would we say, maybe we could say a traditional language in that sense, that you just have your Vim or whatever and you write the code and that's it. I
would say exactly. Vim, by the way, unfortunately, we also just lost the author of Vim. He was a Dutchman.
Oh, really?
Yeah.
I hadn't heard about it.
I had dinner with him once in Amsterdam.
Oh, wow. What was his name?
Bram Molenaar.
Oh, yeah, I know him. I think he studied at the same university. I mean, wasn't he also at the VU?
Wouldn't surprise me. We had dinner in Amsterdam at the time.
So, are you aware of projects that people would know that are actually written in C++? I mean, the obvious, lots of Linux stuff, but I mean like more surprising projects, let's say, that you know of that are written in C++.
I never really look at that, to be honest.
Okay. I thought maybe because of your work on the APIs and stuff, maybe you have seen some stuff where you were like, interesting.
Well, there's a standard tool that everybody uses for translating, for machine translation, where you put in Dutch text, you get English text out, for instance. Pretty much the academic standard for that is Moses. And that's written in C++. And
now that I think of it, I guess lots of AI stuff might be written in C++ for the performance as well.
Yeah. And if you go into the Moses code base, you can still see some of my commits, I think.
Oh, you participated in that as well.
And all the supporting tools that need high performance are all written in C++.
Nice. So maybe to close, if someone after listening to this is like, okay, cool, you kind of convinced me, maybe it's a younger programmer who's never worked with this kind of stuff, where would they start? What would be a good way to start delving into this stuff?
The C++ programming language.
Yeah. Book. Oh, that's the book, literally the book.
Yeah.
It's called, say again?
The C++ programming language.
I'll put a link in the show notes. What is the author, do you know offhand?
That would be Bjarne Strustrup.
Oh yeah, I know that's a very famous book.
Just be sure to get a recent version, because the language keeps evolving, and the latest version, which is about due, it actually changes the way Hello World looks.
Oh, so it does really change significantly over the last few years.
It's evolving.
So by a recent book. Okay, thanks Jeroen for sharing your knowledge.
Thank you for having me.
I wish you all the best with maintaining your C++ code. Maybe we can talk again soon.
Hope so.